Hi, in this video, let's discuss about the kill command on Linux. Kill is a standard tool available on all the Unix environments, and it's also available on Linux because Linux is compatible with Unix, right? It's a Unix based operating system. Now, if you look at the kill command, there are two variants of kill available on your Linux environments. When you normally use the kill command on your Linux command line, when you type in the kill command and pass in any arguments like signal number and the process ID, what gets invoked is generally a bash built-in, assuming that your default shell is configured as bash. So to verify that, if you just do a type kill here, you can see that it shows up as a shell built-in, which means that this is the command that will be invoked when you actually type kill as the command in your command line at the bash shell prompt. However, there is also a kill command available in the GNU Coreutils package, which is installed as /bin/kill or maybe /usr/bin/kill, depending on how your Linux is deployed. In my machine, the /bin is symlinked to /usr/bin. So I think this is what it is. And this particular command is a command that comes from the GNU Coreutils package. And the way you can find out is that if you look at this particular command's help, I do a /bin/kill --help. And as you can notice here, these are the options supported by the kill command that comes as a part of the GNU Coreutils package. So you can just see that you can say kill options, which are the switches that you can pass in here, followed by the process ID and a list of processes that's shown up as triple dots here. So you can kill a list of process IDs if you know what processes corresponds to their process ID, right? And you can send a signal to all of them. And you can also see that it does take an option called -q, which is missing in the built-in variant. If you just do a kill -help like this is going to show you the help of the shell built-in. That's bash built-in for kill, which you can see has very similar options like -small l, -capital L. These options exist, but you won't see a -q switch supported by the built-in kill command that's available in bash. The usage of -q is quite rare. That's the reason why they have sort of omitted it in the bash built-in. When you use a -q switch, you can use the seqq system call. You can make the kill use seqq system call to deliver a signal, and it's most widely used for delivering real-time signals. There are two kinds of signals in all Unixes and Linux. We have the standard signals, and the signal numbers range from 1 to 32. These are the standard signals. After which, from signal number 33 to 64 currently, it's not standardized. It can grow in the future. We don't know that, but for a long time, it has been from 33 to 64. These signals are also called as real-time signals, or shortly known as RT signals. The real-time signals are not used by standard applications. If you look at all the standard programs and applications, they don't use them. And that's the reason why that is omitted in the bash built-in. They're used in very rare scenarios for building your own custom application. Now, coming to this point, many of you would have thought that kill is used to kill a process, right? The name sort of suggests so. So if you use kill and a process ID, you can just get a process terminated. So I'll just show you an example right here. Let me just unzoom my Tmux to bring up the other tabs, saving time. So I'll just run a Vim editor here. So there's a new Vim instance running in this particular tab. So if you want to, let's say, terminate this new Vim editor, I need to know the process ID for that particular process, right? And one way to do that is you can run the ps-ax command here, ps-ax, ps-aux, ps-ef, any option. So just find out the process ID of Vim. So you look at the Vim editor that's there here. This is a process ID of the Vim editor. And you can just do a kill and 14923. This is the standard usage, right? You just use kill and the process ID, and magically you can see that the processes that you have targeted, they get terminated. This can be even a GUI application. So I'm not running a graphical user interface in this session because I have remotely logged onto a Linux machine from a Windows, which is where I'm recording. But anyways, if you have a Linux desktop running and you have opened up some desktop applications on Linux, and if you know the name of that applications through a ps command, know the process ID of it, you can use kill and that PID, and normally they will be terminated. But then there are certain things you should know that kill is not merely to terminate a process, it is actually used to deliver a signal to a process. Signals are very simplest forms of IPCs. When I mean simplest, that means they don't carry a lot of payload, right? You just pass a signal number. Like in real world, we signal people, right? For example, you are in a in a room or maybe a hall, let's say, with a lot of people around, right? Maybe you're in a party hall and you locate a friend of yours who's far off in the party hall. And how do you address your friend? You can't really speak because it could be quite noisy. So you normally wave your hand. That's a signal. You just wave your hand to say that you're here, right? So it's a way of communicating message in the most simplest of forms. We use that mostly using sign language. We say stop or we say go and so on. Pretty much the same way in Linux or all Unixes, you can deliver a signal to a process to indicate some change in state or some event, and the processes would respond accordingly. And most of the common responses that the process will have is to just exit, right? So most signals default disposition, use the term disposition. The default disposition for most signals would be to terminate a process. There are some signals in which a process will not just terminate, it will terminate and generate a core file. And this is mostly for aiding in debugging. It could be some erroneous scenarios, and in such case, the process will dump core while exiting. And there are certain signals which will stop a process. There are certain signals which are silently ignored by the process by default, right? Unless you write your own signal handlers to handle them differently. So we have about 5 dispositions available: terminate, terminate in core dump, and you have stop. A stop process can continue. That is another disposition or another kind of a default handler, and ignore. So these are 5 possible dispositions that a process would respond to when a signal is delivered. I would say more than 50% of the default handlers or default disposition for most processes for signals would be to terminate, right? But many programs or applications can register their own signal handlers to handle these signals differently. They can either choose to ignore certain signals, they can choose to have their own handlers that will do something else. So that varies, right? Depending on the application's make. The standard signals have some standard use case scenarios generally, right? For example, if at all I press Control C when a program is running, let's say some foreground program in the shell, I'm just running this particular tab. So let's say I am running a command like WC, which is supposed to read from user input like this. Normally, this WC command is word count. It's going to count the number of lines, number of words, and number of characters from the standard input at this moment. But I want to cancel this. Normally, when I say Control D to say end of input, you get the numbers. But maybe I want to cancel midway. So, sorry, WC, and you type in something. But you want to cancel it, what do? You'll normally type Control C, right? You'll just type Control C here. The moment you press Control C on your keyboard within your terminal, the kernel delivers a signal to the foreground process in the terminal, and that signal is called interrupt signal, also called as SIGINT. These are kind of names used in the programming world and also in low-level kind of use cases. You call them a SIGINT signal or int signal. So when you type Control C here, the Control C character is printed by the default disposition, indicating that it was cancelled, right? This is what happened. So it's also possible that I can run the same program, and this time I can, instead of pressing Control C, I could use Control backslash on the keyboard, right? I hold the Control key and press the backslash, and I can see that it actually prints something else. It says quit. This also is very similar to cancel, just that it forces the process to quit and, if necessary, generate a core dump. Now, core dumping is disabled in my default shell configuration. How do you know that? Well, in your bash shell, there's a built-in called ulimit. It's used for resource limitation. The traditional way of limiting resources to a process is done by ulimit. The shell has put some resource limitation to itself, and it's borrowed to all the child processes, right? And one such is core dump capability. So when you say U limit minus C, the minus C will tell you whether the core dumping is enabled or not. So if it shows the value 0, that means core dumping is disabled. So I'm going to enable it, and I want to allow it to generate a code to whatever size it possible, right? To do that, I can just run the shell built-in U limit minus C unlimited. And now when I run WC command, and if I just do a control backslash this time, you can see it shows /quit, and in parentheses you can see that it reports as core dump. So there should be a core file generated. I'm not sure if it's created in the current directory. Yeah, it's possible that in some Linuxes the core dumping capability could be handled by systemd. In such case, systemd would have set up a specific location where core dump is generated, and maybe it will process it and send it as a bug report to the developers. That all these can be streamlined, right? But in this setup, which is very simplified, the core file is just generated on within the current directory, assuming you have write permissions to that folder, right? So that's what happened here. So this is a signal that I delivered by putting a control backslash. In some traditional Unix environments, not Linux, some Unix environments which I worked on, I remember using Control Shift K, that's Control capital K, will forcefully kill a process running in the foreground in a terminal. Some processes can simply ignore the Control backslash and Control C. Let's check the Vim editor here. Control C here, it's not handled. I press Control C, but when you press Control C, the Vim editor, that is the new Vim editor or even the good old Vim editor, will print a message here, type :QA or whatever to exit new Vim, right? So it tells you to exit the right way. So it will not let you cancel out by pressing Control C. Many of these interactive programs like the Vim editor or the pager like less and their variants thereof, when they don't handle Control C, when you take Control C, I mean, they handle the signal. Basically what they did was they have registered a signal handler for the in signal where they print some custom message, or they just ignore it. Now, when I try Control backslash here, when Control backslash is ignored by new Vim, you can see this. The reason is because some of these applications have registered signal handlers for the interrupt signal, that is Control C that generates sigint, and Control backslash that generates sigquit, and handle them on their own. But when you try to deliver a kill signal, the kill signal cannot be caught, it cannot be handled, it cannot be ignored. Three things. That is, so when you use a kill signal to a target process, the process will be forcefully killed by the kernel, right? So the process does not have an opportunity to handle that signal gracefully and do some cleanup or ignore it or do anything as such. So that is something to do with sigkill. There are two signals that cannot be caught nor handled. One is sigkill, another one is sigstop, right? There's also a stop signal, which I cannot do it here, but you can try a terminal stop here. For example, if I do a control Z here, Control Z, right? Z or Z, whatever you call it. And there's a Control Z here. You can see that the Vim editor is stopped. Basically, when you press the Control Z combination, the foreground process is delivered a signal by the kernel on the terminal, on the active terminal, and that is sig TSTP. It is called as stopped at TTY. TSTP, T-stop, okay, terminal stop. So this is mostly to aid in job control. To support job control semantics of all the modern POSIX compliant shells, this feature is now inherent in all the modern Unix and Linux environments. So you can always bring it back to the foreground. So you can look at when I say stop, this process stopped, you can do a jobs over here. You can see that it shows job ID 1, it is being stopped, and the process is Vim. You can bring it back to the foreground if you want by typing FG. That's the shell built in to bring the last job to the foreground. So you can always stop a process in the foreground, bring it back if you want, or some process you can push it to the background if they're running. So all this can be done. This is the traditional way of doing job control. This was during the era before tmux and screen. So before GNU screen and tmux kind of tools, people did a lot of multitasking in a single terminal by doing this job control shortcuts, right? So anyways, coming back here, let's come back to the kill command. So I told you that all these standard signals have designated use cases. Int for interrupting a process, quit for, forcefully terminating a process with a core dump, not forcefully, terminate a process and generate a core dump. Kill is to force kill a process. Normally, when you use kill and if you provide a process ID, the default signal delivered by kill, whether it's a shell built-in or the GNU Coreutils variant, both of them are identical in this aspect. They deliver a term signal. A term signal is sort of requesting a process to terminate. It's sort of telling a process, please exit, and the process can have its own handler which can do some graceful cleanup, maybe deleting all the temp files or cleaning up the log files and other things, and then terminating in a very graceful manner. It gives that opportunity, assuming the process has a signal handler registered for term to do that activity. So this allows graceful exit. But certain processes will not exit, will just ignore it. The process can choose to ignore term. For example, the Vim editor does not. Let me tell you one more thing over here. Suppose if I want to find out the process ID of Vim, you would normally do a PSAX and look up for Vim in here and look up this number, right? So many of you who have used a Linux terminal for some time and working on Linux command line will do a PSAX by grep and Vim like this. And you'll also look up the process ID this way. Good, no problem. This works. But if you want to do it in a very scripted manner, in automation kind of use cases, I just want the process ID of Vim, but the output generates a lot of things, which I don't really care. And also the fact is that grep searches for a substring, the word Vim from the output of PSAX command, which also means it will search for itself. And even this process ID is reported, which is misleading. So this grep is the process here, but Vim is a substring and grep is search for that particular substring. So if at all you want to find out the process ID of any program that is running based on the program name, let's say, one of the ways to do that on Linux environments, standard Linux environments, that is try looking for a tool called PID off or PID off. So I'll just say PID off, Vim, very convenient. The beauty of this is that I want to kill a process by name Vim. The way I can do that is kill $off PID off Vim. Works. Command substitution. Now some of you might say, no, there's a better way to do it. Why are you using this PID of Vim and passing it to kill? Why not simply use something like kill all? That's the same thing. So you can also use kill all Vim. The kill all command is sort of similar to whatever I showed you here. So kill all does take a lot of options. I will create a separate video to talk about kill all specific options. And there's also another tool called pkill, which does pretty much the same thing. But they have some interesting switches that I will talk about in another video, right? So when I do a kill all Vim, it works the same way. So if you want to kill a process by the name, I don't know the process ID number, but I want to kill the process by name, I can use kill all. It's a very convenient way to do it. But the caveat or the gotcha for this is that it'll kill all instances of Vim run by this user, that is, right? If you run this as system administrator, as root user, it'll kill all instances of Vim in the system, running by all users. Can be dangerous. You don't want to try it with bash, let's say. It'll kill all instances of bash, which will kill itself also. This particular terminal will exit, right? You don't want to do that. So you should be a little careful when you're using kill all. You know exactly what kind of target processes you're intending. Don't try out some generic process like bash and so on. Use some thought before you use this command, right? If your tool is very specific, a specific tool, it's got a specific name, then this is very convenient. So I'll show you right here. If I just do a Vim here and I will launch another instance of Vim here and maybe create one more terminal, launch another instance of Vim here. Now there are 3 instances of Vim. We can verify that when you run PID of Vim, 3 PID numbers. If I do a kill all Vim, all instances are killed. That's what is known, right? So, of course, you can only deliver signals whose default disposition is to terminate, especially, right? You can deliver signals whose default disposition, default handler is to terminate only to processes that you own. That is, all of these terminal tabs are run by the same user. I've logged in as user called Chandra. My prompt is showing you the same thing. See, Chandra. If a process run by some other user, obviously, you cannot deliver any signals. There could be some signals that can be delivered which are mild, which just sends a signal that does not terminate a process. Some work, but a large part of them, 99% of them, it works only for the current user. The You can only kill your own processes, or you must be root user to kill processes that belong to any user. That's the difference. As a normal user, you can only kill processes that you have launched, right? Programs that you have launched as a process, you can kill that. That's one thing to know about. Now, coming back to the point here, now when you look at the kill command, I told you kill and the process ID, but what else can I do with kill? You can deliver signals. And suppose if I try to kill this shell here, the shell instance that is there, just let me do one thing. Let me try to kill this shell instance rather. Echo $. The process ID of this particular bash shell is 15679, right? 15679. So let me just try to kill this process ID by using kill 15679. I'm just going to clear the screen to run this. It didn't die. It didn't exit. So I can run this a couple of times, and it seems that the bash shell or many of these shells, many of the bond compatible shells, they sort of ignored the term signal. You try to deliver a term signal to them, especially to a login shell, they're just going to say, no, I'm a login shell. I don't want to close. It's a safety. They have done that for a safety reason. So they ignore term signal. So if you want to terminate processes like these, the only option you have is to force kill. The clean option is you go to the shell and type exit or control D. That's what you should do. But maybe for some reason you don't have access to the shell prompt where you can exit the shell, exit from within the shell. You want to tell the shell to exit from outside. You cannot deliver the term signal. So when you do a kill and PID, this is as good as doing a kill minus term PID. Or many of you would have learned about kill elsewhere, would have encountered this strange number, kill minus 15. Let me tell you about these numbers. Don't use them. Not a good practice. Not a good practice. First of all, they are difficult to remember. You can remember maybe kill minus 9 and kill minus 15, but what about for hub signal? What about for quit signal? What about for in signal? There are 32 signals. How many will you remember? And what do you know what those numbers are? Difficult. But it's easy to remember names or signals by name. So always use a name, which makes it more readable. And also the fact is that apart from some very basic signals, there are many signals in the standard signal set. There is the 32 signals that are there, where the signal numbers for the same name or for the same use case varies across different hardware platforms, even if you run Linux on them. So it does. I have faced it. And for example, I remember running Linux on a DEC Alpha 64 long time ago, one such machine, and where the signal number assignment for 6 top and 6 CONT and 6 HLD were very different than what it is on x86 architecture, Linux running on x86 architecture. And it is a little different on Spark architecture. So different hardware architectures running Linux might have certain signal names associated with different numbers. And they've done that for portability reasons with the traditional Unixes that used to run on that platform. It's not the fault of Linux. It's basically, if you're running on SunSpark, the traditional Unix for that was generally Solaris or SunOS. They had different number assignments for 6 top and 6 CONT and 6 HLD. When you port Linux on such a hardware, Linux tries to be compatible with that operating system in the number to name assignment. The same goes with DEC Alpha 64 that used to run True 64 Unix. So these kind of discrepancies can exist. So if you're writing a shell script that has to be portable, where you're using all those specific signals, portability could be a problem. Use a name. When in doubt, it's very easy. And if you want to know what names you can use and what are the number assignments, pretty straightforward. Just do a kill minus L. So let me just zoom this up. So when you do a kill minus L, you get a list of signals supported by the built-in kill command. These are the numbers. 1 is SIGHUB, 2 is SIGINT, 3 is SIGQUIT, 4 is SIGIL, that is illegal instruction, 5 is SIGTRAP, and 6 is SIGABOT. And you can also look at SIGBUS and SIGFP, SIGKILL. This is the famous kill minus 9, you say, right? It's actually SIGKILL. And you have SIGUSR1 and many of them. So there are a lot of them. In fact, up to 32 are, I think the last is 31 actually, 31. Standard signals. Up to 32 is reserved as standard signals. But you can see that 33 is unused. It's reserved for the C library on Linux, the pthread library, I believe. From 34 onwards is available as real-time signals. Though it doesn't make sense to use them with the kill command as a shell built-in. I don't know because whenever you want to use these signals, you should not use the kill system call. Rather, you should be using a CQ system call. And that is where the /bin/kill command comes in. So if you want to be delivering the real-time signals, along with delivering these signals, you can also pass some payload value, which could be a pointer or a number. Normally, you can pass a number if it's a command, obviously. So you use kill minus q and the payload number followed by the signal number and the process, right? I will hope to cover that in another video because there's a retake of this entire video because I did cover all that and the video stretched almost like a 2-hour video. I don't think people will watch a 2-hour video on YouTube, so I just dropped it out. So if you're really interested in knowing how real-time signals work, do post in comments. I will create that video one more time and just focus on that particular topic as such, right? A little bit of C programming is required. So that's one thing that I did. Anyways, I'm just coming back here. Now I told you about all this kill and the options over here. Kill minus L will list all the signal names. If at all you want to, you can also see that by using kill minus capital L. It's the same thing. Either you can use small l or capital L, the output is same. In fact, if you try the /bin/kill minus L, you get a small subset. You can see that there's a difference between a shell built-in and the one that comes with the GNU Coreutils package, right? So it gives you a small subset. It doesn't mean that it only supports these many signals. The others are not shown here, but it will work. You can use them, right? Like you can use all of these names. When you're passing a name, you don't have to pass the full name like this. You can just pass the suffix like hup or int or quit or ill. You can either pass the full name or you can pass a suffix, and kill is smart enough to figure it out, right? Either than telling kill minus term, kill minus term PID, you could also use kill minus sig term PID, right? You can do that. So it works. It works for both use cases. And you can also do a kill minus capital L here. It just gives you the number and name assignments for some of the common signals that we use on the command line. So this gives you only the signals that most commonly people use on the command line, but this gives the complete, elaborate details of the signals. But if you're inclined to know how the signals work, how to use them, and other details, one way to find out is man section 7 signal. You should note that the man pages for section 7 provides detailed, elaborate notes on variety of subsystems on Linux and variety of topics, and signal is a topic. It's an IPC. So you can actually look up this man page. So all that you need to know about signals are there in this manual, right? So it says overview of signals. Linux supports both POSIX reliable signals, even after standard signals, and POSIX real-time signals. It tells you about signal disposition. Remember the 5 dispositions I talked about? The term, ignore, core dump, stop, and continue. It's all there, right here, right? And if you scroll a little more down, a little more below, it'll tell you about how to send a signal using the C program, using system calls, obviously. So all these are system calls that sort of delivers a signal. And if you want to handle a signal, you can wait for a signal by using pause or suspend, or you can handle a signal by using different ways, synchronous way of handling a signal or asynchronous way of handling a signal that's done by using signal handlers. That is registered by a SIG action. That's what is recommended, or the traditional signal system call. But there's a lot of details out here. And here's where all the signals, the standard signals and their use case, what are they used for, is documented, right? You can look this up. So I'm not going to go spend time covering this. Just read through this. It's pretty straightforward. The way you reach here is man space 7 space signal. So all the signals are well documented in that single man page. You read that man page and you have a complete understanding about the concept of signal and different use case patterns. Now coming back here, coming to the kill command here. So when I talk about kill, let's come back to these tabs over here. So I told you that when I try to kill this process with, kill minus term and 15679, didn't work, right? By the way, you can use kill minus term, or you can say kill minus n space term, or you can use kill minus yes and 15. So all these mean the same thing. These switches exist for legacy reasons. That's what I could tell. Okay. So some Unixes, some traditional Unixes expected a minus n switch for providing signal by name, minus s switch for providing signal by number. So they exist for legacy compatibility reasons. But the modern use case can directly use kill minus 15 or kill minus 2. You can see all these variations and the shell seems to have ignored it. But the moment I do a kill minus KILL, which is a synonym for 9, instead of doing a kill minus 9, okay? It's the same thing. You can use kill minus 9 or kill minus KILL, all caps, and followed by this process ID, and just see what happens. The shell terminated, right? So this is what happened. You can also do other things, like say, for example, I told you, we can either terminate a process or force kill a process. We learned how to do that, right? Using normal kill, that is normal terminate, or force kill. To force kill a process, use kill minus 9 PID or kill minus KILL. That's what I would prefer, followed by the process ID. And the process IDs can be a list of PIDs, by the way. So if at all I have multiple instances of Vim running, like I have one instance here and another instance here. And I try to bring up one more tab and run one more instance of Vim. Now we have like 3 instances of Vim 8 are running. Let's say I want to terminate all these 3 instances of Vim using kill. You know the process ID of it? These are the 3 instances that you see. Now I can do a kill and minus term. The minus term is not really required because the default signal that will be delivered will be this term signal. But I'm just trying to be more explicit to say what signal will be delivered, right? And you can do a 16. Okay, let me just paste it off from my Tmux clipboard here. Yep. So all 3 instances are terminated. So you can actually use kill with a list of PIDs. A signal will be delivered to that entire list, right? What other useful signals I can use? Well, it depends on the use case. Let me show you one example here. Then another terminal, I'm running a dd command here. You can see there's a dd command running as root user, by the way. So I'm trying to make a complete backup of my SD card onto my pen drive. Actually, that's another SD card connected on a USB reader. So I'm trying to make a snapshot backup of it using dd command. I forgot to use a status is equal to parameter for dd command, which means that I don't know what's the status of it. I don't know how much is being copied so far, right? And this can take a long time because this SD card is 64 gigabytes in size, and it does take a long time to make a replica of this. I started this copy before I started this video. Now I want to know the status of how long has it been since this dd command is copying and how many blocks have transferred. The dd command specifically has registered a signal handler for a signal called USR1. It's called a SIG USR1. If you do a kill minus L, you will see that listing. There's something called SIG USR1. These are for custom registration by the user. You can see that SIG USR2 is here. You'll find a SIG USR1 in here. So when I deliver the signal, I want to find out the process ID of dd command. I do a PID of dd. By the way, the dd command is run as root user because only as root user I can run that command apparently, doing a raw copy of my SD card to SDA, which is actually my pen drive. Okay, it's not a pen drive, it's another SD card connected on USB card reader, right? So I'm just making a copy of that. But then I want if all I try to deliver a signal to that by using kill minus USR1 and this process ID, of course, you'll get an operation not permitted because as a normal user, you can only deliver signals to processes that run with the same UID, that is the same user credentials. So, but for now, if for all I want to do this, as usual, sudo, and you can see what's happening here. It prints a message, a status message. So this is very, very implementation dependent. So the dd command has been implemented in such a way that it handles USR1 to print immediate status report on how much has it copied. Looks like it's copied roughly about 21 gigabytes, 19 GB bytes, let's say. Anyways, so if at all I go to another terminal, I'll open another terminal here. And here, let's say that I'm going to run a Java program. Yeah, I'm in that folder, I guess. Testing, yeah. So there's a Java program. I just compiled. It's a simple hello world program, nothing sophisticated. It can be any sophisticated Java application, right? I run it in a JVM. So I'll do a Java and hello world. Just waiting for user input at this moment. I'm using console.readline. It's going to wait for user input. When I press enter, it's going to exit. I'll rerun this again. Okay. So this means this process is still there in memory. Let me just cut the screen and let me just do a PSX. You can see that the JVM is running. The Java virtual machine is still there in memory. If at all I deliver a special signal to this JVM, which is SigQuit. Normally, when you do a SigQuit on a foreground process, it terminates a process and generates a code up. But the Java runtime, I sort of implemented a signal handler for SigQuit, which does something else. So I'll show you what it does. So do a kill minus quit and 17197. It dumps the complete thread information. You can see this. It's still running, but the JVM took control, printed the diagnostics information. See, full thread dump of OpenJDK, blah, blah, blah. It tells you all the details, tells you about all the threads that are running. So it tells you which thread is currently active and all those details are shown, right? Thread stack is shown. See, it shows there's one thread that's runnable and it's actually waiting for user input. As you can see that, right? It's waiting for user input. File input stream, read bys, blah, 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 called by console line reader, called by console or read line. And there's another thread, which is a reference handler thread, waiting for reference point pending. And there's another thread, which is a daemon thread, finalizer thread. And we have signal dispatcher thread, and we have so many threads here. So this is Java specific feature, right? So different applications might use or repurpose certain standard signals like these for their own use cases. So you just need to look up their manuals. I also know that many services or many background daemons that run as services on Linux, like Apache Web Server, PostgreSQL database, MySQL database, or MariaDB, or many of these servers, they mostly handle the hub signal, the hang-up signal. I will show you an example for that. I do have an Apache server running. By the way, for getting this thread dump, you don't need to use kill command. I will show you another way to do it. Let me just zoom this up first. You can anyway, if you're running on the foreground in your terminal, you could just put a control backslash. We'll do the same thing, because control backslash on a foreground process in your terminal will deliver a SigQuit to that process, right? So you get the same output and you run JVM. But if you want to do it from another terminal, you say kill minus quit to achieve this. Likewise, there are some services running on my system. I have, for this training for this video purposes, I've created certain services. For one of them is the Apache Web Server, a very popular web server that powers the internet, right? So I just launched a very simplest configured Apache server here. And just because I want to show you the logs, and there's also a PostgreSQL server running, which you can see here. They have multiple workers created, right? So Postgres, this is the main server, and this has created a lot of workers underneath it. Similarly, even Apache has there's a main server. It's created a couple of these thread workers again, I believe. So how do I know that? Is when you look at all these daemons or background services, the main process would generally have a small s associated with it. But in PostgreSQL, it looks like all of these are main. So all of these are main processes, looks like it, right? So in this case, so you look at this main, background writer, all of these are critical processes. If any workers created, they'll not have a small s. A small s means they're session leaders or also process group leaders, right? The same goes with even Apache server here. You will see one of them having a small s in their status listing. 1 minute, let me just okay, here you can see that right here. 11309 is got a small s here. This is a session leader, and the others are workers, which is here. And the small l here indicates there are multiple threads in this worker. It's multi-threaded. You have a couple of multi-threaded workers being created, but this is a session leader. So these are like the service managers. They were launched by the service managers, right? So, for example, if I know the process ID of Apache server, mainly the session leader that is there here, 11309. Let me show you something. Let me just cut the screen and there are multiple screens here. Let me just close the one of them, and I'll just do a tail minus f slash var slash log slash apache 2 slash error log. And just watching the error log of Apache server, right, which is currently running. If I do a sudo kill, obviously it's running as root. So it's not running as root, it's running as not my user account. It's running as a different user. So I need to use sudo to deliver signal as root user. I do a kill minus hup, HUP, and this process ID. What was the process ID of it? I lost it. Okay. I can find out from here. I think it is 11142, I guess. Yep. So I'll just run this. I'll know it. 11142. Oh, it's not that. I think it's yeah, it is 11130. I think I restarted a couple of times. 11309. I can see what happened. You got a message here. You see this? SIG hub received. Attempt to restart. And it tries to prints all the logs based on the configuration. I've not done any changes in the config, so you'll see some warnings. You can ignore it. So the moment you use a hub signal or kill hub, when you use a SIG hub signal to these background services, a lot of them, they are configured to instantly restart. They'll do an instant restart when you do a hub. In fact, the Apache server is configured to handle USR1 that also will do a more graceful restart. I can show you that. So here I'll just put some hyphens to separate it. I use USR1. You can see out here. It shows npm event notice, and you can see SIG USR1 received doing a graceful restart. Maybe it does more proper restart. But all of these use cases, one thing to note is that they don't really terminate themselves and start a new instance of themselves. They don't do that. They just reread their configuration and restart their routines. That's what they do. So the process ID has not changed. So that the server does not incur a downtime, right? That's a beneficial feature. So for example, the main use case is that as a systems administrator, if you make some changes in the configuration file of this server, you made some changes to your http.conf for Apache configuration file here, and you believe that you tested the configuration in the testing environment and it worked perfectly fine. You deployed to production. You want this server to just reread that configuration again and reinitialize itself without incurring a downtime. And for that use case, this hub signal is used, or even USR1 is used for Apache server alone. The same applies even to PostgreSQL. I can just show you the PostgreSQL logs too. I think that's located in here, /tail -var/log/ Postgres main.log. I think these are all default configured settings in my Debian setup on my Raspberry Pi board. Running PostgreSQL on Raspberry Pi is that one in SD card. Not a good idea, but I used it just for this video, right? I'm not going to do anything sophisticated on this. But yeah, you can see that this Postgres log is shown up here. It tells you all these details. What I'll do right now is I'll just use some hyphens to mark this boundary. So any new logs will come up below, right? So I've did a tail -f. It's going to keep following, waiting for inputs coming from the logs, right? Changes in the logs. So let me just find out the process ID of it. Is there a way to find out the process ID there? Yeah, it is. It's reported right here. 9891. I think I should use this. So let me try this. I'll just do a sudo kill minus HUP 9891. Let's see this. The moment I deliver a SIG hub, it says log, receive SIG hub, reloading configuration file. So you make some changes to the config file of your PostgreSQL, some changes in settings, and you want the server to just reread those configuration and reinitialize itself with the new configuration. The way you do that without incurring a downtime is using the hub signal. This is just the example I showed you. This is applicable to many servers. It works for SSH. You're using OpenSSD as your SSH server, and they understand hub signal. Many services use hub signal. Some of them could be configured to use SIG USR1, or some also use CONT, signal continue, for some reason. SIG CONT. So they vary, right? Depending on the servers, different signals could be registered with their own handlers in those applications to do some instant restart or print some diagnostics or other things, right? So that's something that you should know on how you can use the kill command to deliver different signals for different processes, right? So this pretty much ends this video. So before I end up, let me add a plug, obviously. So yeah, if you are looking for trainings on the more formal training courses on Linux command line or Linux kernel or more topics to follow, I'm making more online videos as paid training courses, obviously. There are two places where you can look up. If you live in India and if you're willing to pay by Indian rupees, obviously, and you can head over to slashprog.com. This is my official website. Just go to slashprog.com and the featured courses are here. More courses will be added in this time, in due course. I started to make more courses available online, so you can just register here. But if you are not in India or if you cannot pay by Indian rupees and if you live outside India and you wish to pay by your home currency, basically your country's currency. One place to look up is also in Udemy. I also put all these courses on Udemy. You can just look up at udemy.com/user/chandrasekhar-babu-3. Yeah, my ID is that. I recently got an account in Udemy. Yeah. So anyway, so you can just look up this particular user ID or search for my name. If you find this face, you can recognize me. And the same course is also available for the international audience here. Yeah. So that's something that might be beneficial if you are looking for a more end-to-end trainings on these topics. Most of these I'm focusing on the foundational courses first. As we move along, I will be making more advanced courses. The YouTube video is more of a side project of mine. You will see certain things overlap, but not a lot. The YouTube video will talk with like an offshoot from these. So if you take up the course on Introduction to Linux Command Line Interface, I talk about all the basic concepts, but not things that I covered in my YouTube video. I'm very clear on that. So the point is that people who register for this training will also watch my YouTube video. I'm hoping they do and figure out some interesting nuggets that I cover on YouTube. But there are certain things which could be related, like permissions, file permissions, and all these. I had made videos earlier in YouTube. You will see that all formally added, not the YouTube video, but remade in this course. So you can just look out for this course and enroll to them. If you're interested, I'll let anyone know. If you have any of your friends or acquaintances who are interested to learn on Linux, Python, and so on, you can suggest this particular website of mine. So thank you very much. So I hope to see you with, I hope this particular video was useful. You did learn some concepts on kill and how to use kill command. And if you're interested to know more about how real-time signals work, or you want to know how to use that kill -q switch and so on, just do write on comments. I will make videos on them and I will post it accordingly. Thank you very much. Meet you in the next video.